Hi, I'm Noah Heller, and I'm the software lead of Redshift 4048. When I joined my high school robotics team, I thought success was about individual skill. During my first year on the team, I took on a solo project to determine our robot's position on the field. I fed data from a LiDAR into a SLAM algorithm running on a Raspberry Pi as a ROS node. This data was then sent over network tables and combined with wheel odometry using a common filter to predict the robot's position. After months of hard work, I finally got it to function at home. But when we arrived at the competition, I realized I had overlooked something crucial. I had no way of starting the program at the beginning of the match. That experience, although disheartening, taught me an invaluable lesson. Teamwork is everything. If I had worked with my peers, that simple oversight could have been avoided. In school, I was taught to compete against my peers. In robotics, I learned that collaboration is what leads to innovation, and that was exactly the attitude I took into next year's game. Fast forward to 2024's FRC game Crescendo. As soon as it was announced, I knew exactly what project I wanted to work on. I had just completed a projectile motion unit in physics and was more than excited to try and autonomously shoot notes into the speaker from anywhere on the field. Not wanting to repeat last year's mistake, I eagerly teamed up with a senior who could help me with the project. Together, we were able to create a physics-based simulation of our shooter that could calculate the angle we needed to shoot based on the robot's X position, Y position, and the rotation of the robot, as well as the current velocity of the robot and the initial shooting velocity of the note. One major advantage of the physics-based approach was that it allowed us to shoot while moving, which was a limitation of the standard interpolating map approach many other teams took.
Move back.
That year, I also transformed our autonomous routines. We went from simple move forward commands to developing complex paths that integrate vision data and finely tuned wheel odometry. I built a custom network protocol for transmitting vision data and helped design a complete vision pipeline using ROS, allowing us to build flexible autonomous paths for competition. The work paid off, and we were recognized at our district WPI event for having the most consistent 4-piece auto. This led us to winning the WPI district event as alliance captains for the first time in our team's history. For this year's game, I am automating scoring on the reef. I am currently training an AI model to recognize coral scored on the reef and using a custom strategy algorithm to decide where the best location to score the coral is. Starting this project, I knew I needed a large data set of coral being scored on the reef, and that I did not have time to capture or annotate thousands of photos of coral being scored. This is when I decided to use an alternative approach and use NVIDIA Omniverse to generate a synthetic dataset of coral being scored. I introduced slight variations in starting coral position and velocity to simulate different scoring angles and shooting velocities. Utilizing NVIDIA Omniverse, I am able to automatically generate thousands of annotated images for training an AI object detection model. Beyond competitions, during my time on the team, we've restructured how we program our robot. When I joined the team, we were programming the bare essentials. We had subsystems and commands that moved motors. This meant that when things went wrong, as they often did, we had no logging to diagnose the problem. Seeing this limitation, I developed a framework on top of AdvantageKit, enabling more efficient logging and debugging, yet still being accessible to new students. Since my first year on 4048, my team has grown in incredible ways. One major improvement has been the communication between our hardware and software teams. Before, the hardware team would build the robot, and the software team would often feel frustrated by the hardware they received. Now, we collaborate from the start, discussing everything from degrees of freedom in our mechanisms to the placement and types of sensors we need. Being part of my robotics team has shaped me into the engineer, leader, and teammate I am today. It has shown me that innovation doesn't happen in isolation, but when passionate individuals come together to push the boundaries of what's possible.